Hey, have you heard? We are thrilled to welcome Capturing Reality to the Epic family. Their software, Reality Capture, is the state of the art photogrammetric software for 3D scans, yielding unparalleled accuracy and mesh quality at speeds many times faster than competing software. Together, we will make their world class photogrammetry technology more accessible and affordable, including direct integration into Unreal Engine, and bring the real world to even more digital experiences. With recent refinements to Control Rig, you can create a range of expressive animations in Unreal Engine 426, no third-party apps required. See how these improvements make crafting complex rigging solutions easier and start bringing robots to life yourself. Watch the Using Control Rig for Unreal Engine presentation on our YouTube channel. And if you're still working on those New Year's resolutions, march over to Unreal Online Learning, where we've added new free courses. Find out how to prepare your 3D models for import, how you can use blueprints to prototype games, plus more. French fashion label Balenciaga recently teamed up with Dimension Studio and Streamline Media Group to create Afterworld, The Age of Tomorrow, a cloud-based real-time experience designed to showcase their Fall 2021 collection. Pop over to the Unreal Engine feed and see why it was a game changer for the fashion industry. Beyond what you see, real-time technology is being used to enhance what you hear. Forward-thinking organizations like global consultancy Kundal, who offers engineering services for sectors from residential to healthcare to aviation, and Chalmers University of Technology's Digital Twin City Center are using Unreal Engine to improve urban planning and the acoustic design of buildings. Find out how on our feed. Once your acoustics are optimized, become a digital DJ and headline your own virtual festival in Fuser, the latest rhythm sensation from the mix masters at Harmonix, the studio behind classics like Rock Band, Amplitude, and Dance Central. Put your hands in the air and learn more about how they created their most robust and customizable music creation tool yet. Training autonomous vehicles, robots, and drones requires highly realistic environments, which in turn require huge amounts of data. So how do you solve this conundrum? For Duality Robotics, the answer has come from the world of animated films. Steer over to the feed to learn about their innovative solution. If you're looking for weekend plans, tune in for a live performance of Dream, a virtual experience inspired by Shakespeare's A Midsummer Night's Dream, hosted by the Royal Shakespeare Company. With Puck as your guide, you're invited to explore the forest from the canopy of the trees to the roots, meet the sprites, and take an extraordinary journey into the eye of a cataclysmic storm. The show runs from March 12th to March 20th. Visit dream.online to learn more. Now for our top weekly karma earners, many thanks to Everynone, Clockwork Ocean, Crew Dimer, Nazvik, Hakaishin 0895, Shadow River, Grim, Leo Miranda 518, CCDDEE60, and Unreal Peter. First up in our community spotlights is Promethean AI, which is a semantically aware AI that was created to help you make games and environments more quickly and while removing some of the tedious bits. It learns your assets and materials, then you can simply ask Promethean to start building for you. Learn more about the Epic Mega Grant recipient and its free public beta at prometheanai.com. Get ready to pew pew in Aurelia Stellar Arising. In this mobile, 3D turn-based Fleet v Fleet space combat game, choose between two factions and fight for control of the Aurelia system in over 77 missions. Download it from the Google Play Store or the iOS App Store today. Last up is a handy tool from Ryan John 2040, the Unreal Network Profiler. They've created an updated, easy-to-use interface that's now available to download from GitHub for free. Check it out! Thanks for watching this week's news and community spotlight.
Hey everyone, and welcome to another episode of Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and my guest today is Richard Cowgill, RTX Unreal Engine evangelist from NVIDIA. Welcome back to the show.
Thanks. Yeah, it's good to be here again. I had a fun time last time, so I hope we can cover all things DLSS related.
Yeah, that's what we're doing today. Last time we went through a couple of topics, but today the plugin DLSS for Unreal Engine is actually available on the marketplace, and we're going to talk a little bit how to use it in the future.
Yeah. So I should probably start by explaining what DLSS is for anybody who's new to it. DLSS stands for Deep Learning Supersampling. And if you break that down, it does exactly what it describes. So it's using deep learning algorithms to supersample an image, upscale it, and so essentially take a lower res image and make it higher resolution, but do it intelligently, not just the traditional way of upscaling an image and then sharpening it and then kind of hoping everything looks right. This is using intelligent artificial intelligence programming to enhance the image, bring out details that would otherwise not be visible, and at the same time give you like a real significant performance boost. Another way to look at it is it alleviates a lot of load on the GPU. A lot of games, especially in an advanced engine like Unreal Engine, uh, a lot of your time is spent trying to optimize the scene for GPU tasks. Maybe you're doing a lot of dynamic shadow casting. Maybe you're doing a lot of like fill rate intensive effects. So anything where the GPU is a bottleneck, DLSS can help.
Yeah, and you showed me some impressive results, so why don't we go ahead with the presentation?
Yeah. So let's look at my screen if we can switch over to that.
Good to go.
Okay. So I'll show you the step one is when you first off, you just go get the plugin. We have it up on our website. After you sign or after you agree to an end user license agreement, you can download it. And DLSS, it works with Unreal Engine 426. So when you get the plugin, you have everything you need. You can just step through that a little bit. You'd want to now. There's directions for all this, but I'll walk you through it. What you want to do after you get what you need here is this is like your plugin folder. Let's say I've got it for 4261. So I would grab all this content here, copy it, and you need to get to your plugins directory in 426. So I would surf to this location, go into my engine, plugins, runtime, NVIDIA. If you don't have an NVIDIA folder, I think you should by default, but just in case, you make one. And then make a DLSS folder and just copy this plugin content into this folder here. And that's step one. That should get you good to go.
Are you required to put it in the engine directory, or could it be on a per project basis as well?
It could be also be in your project folder. I think the reason why we document it that way, I believe, is because somewhere I think it's been said that or written that that's technically correct plugin installation. But I think with plugins you can also make a plugins folder in your project and put it in there. Either should work. But I'm just wanting that's what we document, and that's what we I think that's the official method. You're not allowed to redistribute the source is the thing. So you just nobody should be doing that anyway. They're probably not passing their project around, but but as a compiled binary, there's no problem with distributing your project with DLSS. So yeah, once you've done that, let me load up a basic project here. I've already enabled DLSS for this, but I'll walk through all the steps for setting it up.
And we are taking questions for our Q&A. We might answer them in the middle of the stream or at the end during our Q&A session. So feel free to submit all your questions in regards to DLSS and NVIDIA.
Yeah. So here I've got a basic test project. I'll explain more about this later. I've set it up for ray tracing, and what I've done here, even though this is a very simple project with simple graphics, I've attempted to kind of bloat this out intentionally so that DLSS has something to do, so that we can get a nice frame rate boost. And I'll just sort of be a representative of how you might put a lot of advanced graphics in your game, so that the GPU is has something to chew on. Anyway, once you're all here, just go to your plugins, and you could search for DLSS, and you would just enable it, and then you would need to restart the project. But once you've done that and you've restarted, and I would just note that to carefully follow the PDF instructions as well, because there's a lot in there that's documented. If you run into any trouble, if you hit any snags whatsoever, it's all there. Common ones might be you're not on the latest Windows 10 version, or you need to update your GeForce drivers. But if you've done all that, after you activate the plugin and restart the project, if you go up here into your viewport, you'll see a DLSS settings menu. So it then becomes active and built in, and that's how you know it's working, because it's right there. So let me set this up. Okay, so this is with DLSS off. And if I'm skipping anything, I mean, please, seriously, just stop me and ask questions here. But
I'll be on you.
Sure. Okay. So I've got, you can see what the frame rate is. By the way, I'm running on 2080 Ti right now. So it's fast hardware. The 2080 Ti is no slouch, right? This is a very high end, very powerful graphics card. But it's not the highest end. Faster cards would give you better performance. And like I said, this is a ray trace scene where I'm doing. You can see it's got the nice penumbra shadows that ray tracing gives you. So sharp at the base, gets softer as it goes out. Same thing over here. I've set the sampling up on all the lights. So this is a ray trace skylight, ray traced ambient occlusion, and a ray trace direct light. And all of them have their sampling set up to either like a value of 8, or in the case of the skylight, I set it to 16. So that's why it looks so so smooth, right? It's there's very little distortion. There's almost none. I mean, maybe a little bit if I turn the camera real fast, and you'll see the denoiser catch up. But it's it's looking pretty good. It's performing decently. Almost 60 frames per second is okay. I'm running in 1080p on a 2080 Ti. That's all right, but we'd like it to be faster. So that's where DLSS comes in. If I go to my menu here, and I'll set it to quality mode. You can go faster with the lower quality modes, but if I set it to quality, that's what it does. So you see the frame rate there, and very arguably, image quality has not taken a hit. In some cases, it might even improve. But here I've taken a ray trace scene that's sort of, like I said, it's kind of bloated. I'm oversampling. I'm kind of doing too much. It's not very optimized, I guess you could say, even though it's simple geometrically in terms of, how much ray tracing activity is going on here. There's a lot happening because as you can see, it gets at those nice, shadow within shadows and soft shadows where you want them, and it looks very solid. Go ahead.
Those settings there for the plugin, you can expose them to the end user, the player as well, right? And they can adjust them during runtime in the game.
Yeah, absolutely. I can show that real quick. So So I have some simple blueprinting here. But yeah, your most once the DLSS plugin is active, you have access to blueprints to control it. You can still do console variables; those work as well. Excuse me. Let me see. So all of your console variables are going to be under rngx.dlss, and there you can see the relevant console commands. And there's some here that I think are not available, or maybe less available than in the blueprint, but that gets sort of very particular. So you can enable it and disable it. You can set quality, you can set sharpness. You can do all that from here if you want. But if you prefer blueprints, we have that too. So here's a very, very, very simple blueprint where, on level start, we can test for this. It's all under DLSS. So if I do a search, context sensitive, and type DLSS, I get my DLSS blueprint scripts. And in this case, I can test to see, is DLSS supported? Is it supported on this hardware? This function here will, is sort of looking at, do you have an RTX card? Do you have, are you on the latest drivers? And you can test for that too using blueprint functions. You can test to see which driver version a user is on, and then make your code appropriate. But this would all potentially feed into like a user interface, right? Like where the user can go into his preferences and turn DLSS on or off, set the quality mode, et cetera, et cetera. So here I'm just doing a very simple thing where it's checking to see if DLSS works on this hardware. And if it does, put it in quality mode and set the sharpness value. If it doesn't, if it's not supported, just turn it off, and that's okay. So I'll just compile and save that. And I think I did another thing up here, just a quick thing. Yeah, where if I press the tab key, I do a simple flip-flop where it, turns DLSS on and off in real time. And like I said, you can use these menu functions to pick what you want, or you can do it the old-fashioned way, which is just execute a console command. Maybe that's how you prefer to set it up. So yeah, getting back to this, yeah, I'll run it, and I think yeah, there we go. So that's DLSS off, running TAA, so sort of the standard anti-aliasing that most everybody uses today. And then if I turn it on, it almost doubled my frame rate. And like I said, there's most of the time quality will improve, especially if you're in quality mode DLSS. There may be some edge cases where it's not as good as TAA, but I think 90% of the time it's equal to or better. And there's just from a visual standpoint, and you get the significant frame rate boost. And here down at the bottom of my screen, you can see it's got some debug information. We supply with the plugin in the source. There are some Windows registry keys, so you can drag and drop those into your, or you can double click them and they become active in Windows. And this is just for my sanity as a developer, right? End users won't see this because this is just on my local machine. But if I want to know if DLSS is actually working and if it's active, I have this ability to enable a registry key and then see the output down there. So down here at the bottom of the screen, you can see that it's got in quality mode. Quality mode is I'll step through each one. Ultra performance is 33% input resolution. Performance is 50% input resolution. Balanced is 57%, and quality is 66%. So I'm doing quality mode right now. That means that it's rendering the original image is 66% of this size. So you can see what that is. It's 1281 by 694. That's the input pixels, and then it scales that up to 1920 by 1040. So basically 1080p. And you know, I can swap back and forth. So there's standard anti-aliasing, full resolution. Basically, that's, you know, every pixel being drawn.
And that should be temporal, right, by default.
Yes. And so there's with DLSS active, frame rate goes up considerably, and you can see like the input resolution is 66% now, and it's scaling it up. So, but I really want to emphasize this point about the scaling thing, because you'd say, oh, well, I don't want to, you know, draw 66% of my pixels. Well, if that's all it was doing, I would totally agree with somebody who had that concern, because that's sort of like how games have been made to date, right? Like, I don't know when it started exactly, probably around, you know, maybe 2000 with the Xbox One, and maybe it was done before then, maybe around like the Halo 1 days or something. But most games to date, I shouldn't say most, a lot of them will render the game at a lower resolution, scale it up in real time, and then do something on the back end to try to clean that up. They'll do like basically a real-time sharpen filter. This is sort of standard practice. And you know, some of the games will, especially on the PC, they'll give you an image scaling option. So maybe you're not running the game at 100%, you're running it at like 80% or something like that. Most, you know, major titles do something along those lines. DLSS seeks to improve on all that behavior, right? Because now what we're doing is we're using the tensor cores of the RTX card, and that's part of the reason why DLSS requires an RTX card, is because only those cards have basically AI cores. They're the tensor core hardware is making this possible. Makes it possible for us to feed in a lower resolution image, scale it up in real time, and then reconstruct missing details, and not just sharpen the result, but improve the result. Actually, make the details cleaner in some cases. And it does this because sort of the best explanation is it's a set of AI algorithms that have been trained to know what things should look like. It was trained on very high resolution images, like 64,000 pixel images, very high resolution photographs. Taught how light should behave, how details should look, and all this training was done for a very long time to teach the code, really, so it could teach itself how images should appear, like perceptually to the human eye, and then like sort of fill in the blanks. So it's not just upscaling it and sharpening it; it's doing a lot more than that. And as you can see, you get a nice performance boost out of that. It's like once, you know, I think when we started with this, we had DLSS 1.0, and it was this is one of the big changes with, you know, now with the plugin, is that when DLSS was first invented, it was slow start. We had to get it trained with very specific apps. We had to teach it like with this particular software to make sure it would produce the right details and things like that. But as time went on, we've been able to improve the software, make it more generalized, so it can reconstruct those details from any kind of image. It doesn't matter what it is, even stylized, whatever. So that enabled us to release the plugin where the plugin can work on any kind of rendered image, and it will do the appropriate thing. It'll know how to take a lower res image of whatever it is you're trying to draw and upscale it, and it's literally an enhance, where the artificial intelligence is inserting and creating and enhancing detail That's important to like basically how people perceive imagery. I guess it's like, yeah, that's sort of a how I might explain that. But I mean, the benefits are enormous. As I move around, everything looks great. Having a higher frame rate in this case actually helps to stabilize the ray traced image with the denoise pixels, because the faster it can update, like when I whip the camera around, the quicker it can produce a smoothed out image in this case.
John Stoll was asking, can you use this even without ray tracing enabled?
Oh yeah, the scene doesn't need to be ray traced at all. It's for any kind of image, raster, ray traced, any mix in between. Yeah, the only requirement from a strict requirement side is that it requires RTX hardware to run. There's not much we can do about that, because in order to reconstruct that image really quickly, you need tensor cores. You need some type of neural net hardware, basically, something that's really fast and really powerful, capable of doing billions of operations per second. So, but yeah, that's all part of it. But yeah, it does not need to be ray traced at all. I can get more granular about what's going on here from a cost standpoint.
Yeah, I think we're all excited about that.
So let's see. I'll show you a stat GPU. So let me turn it off. So okay, this is with DLSS off. So I'm looking at just my GPU cost here. If you're familiar with optimizing scenes graphically, you're probably used to looking at the stat GPU command. And you can see here, like my biggest cost, this is a pretty outlandish cost, is almost 8.5 milliseconds going to a ray trace skylight. That's a lot. But like I said, I turned ray traced, shadow casting skylight on, and then set the sample count really high, so there's lots of pixel operations happening, in order to produce a nice clean shadowed image. And then you see past that, my next cost is my lights cost, and ray tracing ambient occlusion is very high. But this all makes sense because, like I said, I've cranked those values up. But all that sampling is it's really on your screen space, right? So if you had a way to reduce the amount of pixels that you're inputting into the system, and then you could scale it up somehow, then in theory you could shave a lot of cost off those things and make them more affordable. So that's where a lot of the savings are coming in this case. So let's see, if I do, so when I turn it back on, you'll see the skylight lights and ambient occlusion values all drop, and pretty much everything will go down too. But I'll turn it on, and there you can see everything went considerably down. And there's DLSS off, and you'll note there's a line in there for DLSS, right? DLSS itself is not free. It takes typically about maybe a half a millisecond, some in that ballpark, for DLSS to do its real-time operation. But I mean, in this case, I'm spending a half a millisecond to shave off like 6 milliseconds. So that's a good win. Maybe even more than that. What is that? Reduces from 20 milliseconds down to 11. But the DLSS, there you can see the DLSS cost is 0.64 milliseconds.
The numbers speak for themselves.
Yeah. Yeah. So, okay.
No, I didn't mean you. I meant...
No, you're good. So yeah, and it's I don't know. You might be okay not doing DLSS, you might say like, I'm good with 40 frames per second. I don't need more than that. But there's lots of circumstances, maybe where you want 120 frames a second or 200 frames a second. It can become very important, depending on the use, the application, or like I said, maybe you're just trying to do something really expensive on the GPU, and you're struggling to hit 30. DLSS can get you over that line in some cases. Maybe if there's no other way for you to optimize your scene. I would point out though that, and I think this is just generally good. Like I'm not advocating that, oh, you just put DLSS to make a slow thing run fast. Fundamentals are still very important. Let me get that back up. Knowing what your base pass cost is and what a base pass is, and there's lots of good documentation out there about things like your shader costs, your base pass, your pre-pass, your mesh draw calls, and you want all those things to be in good shape. And when you do that, when you have a fairly well constructed or fairly well optimized or at least well set up project from the get-go, and then you put DLSS on top, that's where you get the real benefit, right? Because if you're, let's say, for example, if you have just a really high draw call count and you haven't tuned the amount of meshes that you're rendering, draw calls affects CPU. That has a lot to do with CPU to GPU performance, and you can end up with a CPU bottlenecked project. So, optimizing the GPU probably won't help you that much. And then in that circumstance, if your draw call count is really high, you put DLSS on, you may only get a few frames per second. You're not going to get the boost that you want because that's not where your bottleneck is. So this is where it's just all the old rules still apply. You still want to have everything you would do for ray tracing, raster. It doesn't matter. You want to have just a well-constructed scene for all those basics. And then if you do that, like I said, DLSS will really shine. So yeah, is there anything else I could show with this basic project here? Oh, I guess I could show.
Yeah, we have a couple of questions if you want to tackle
Sure.
some now.
Yeah. Go ahead.
Some in general, some stuff that we might be able to try in this scene. Atlas Bay VR asked, does DLSS work with scene capture actors? I only got it to work with regular camera actors.
Scene capture actors. So, like, that sounds like you want to capture something, put it to a texture.
Mm-hmm, like a render target.
Yeah, render target. So DLSS will work on the final image. I mean, if you have like a TV screen and you're rendering your texture like live to that TV screen in the game, then DLSS will work on the end result there, like the whole scene. It's not going to work on it individually before the basically the scene is constructed.
Let's see. There was another question here from Incanta Games. They asked, how does enabling DLSS for my project work for players with non-NVIDIA GPUs? Do I need anything extra for those GPUs, like shipping another binary?
No, you don't need a different binary. We build this into the plugin, so there's fail safes here, where, like I said, you can just do wherever you set up your game preferences, if that's in your UI blueprint or some other method, or I believe we supply the source code when you download the plugin. I'm not sure about that, but I mean, like if you have however you set up your preferences, I mean, you can always test to see if DLSS is currently supported and have fallbacks to that. And if it's never going to break a system because it's the fallback is always going to go to standard anti-aliasing TAA. you can change that default. There's commands and options to do that. But with just simple scripting, like just even like this, just to test, is it supported or not? If it's not, make sure it's off. This is probably even redundant. I wouldn't have to, hook up anything there, but just for sanity, maybe go with something like that.
Yeah, we can grab another one here. Matias Casagrande asked, I have been testing DLSS and noticed a lot of blur when rotating the camera. How to fix it?
Yeah, so in the documentation, there are some console commands and some things you can try that have to do with motion vectors and a few other details. Now, if you step through, let me point you to where that is. If you go into the plugin, the installation guide will, get you going. Like this is everything I stepped through at the beginning. Like go to this folder, put your plugins there, run it, you're good to go. But if you go to the quick start guide, the next document in the list, this gets a lot more granular and will step through complex issues. So you go down here and you can see that, you might have some problems with motion vectors, for example, which it's hard to say, or it's hard for me to say right now exactly what's going on without, seeing the project, seeing the content. But most every kind of solution you're going to want is in here, and you can, we document what the console variables are. This is the more advanced stuff, and give it a try and see if it helps your project. Now, if it doesn't, then this is constantly improving software. It's constantly developing. So we want to make sure that it's going to work with your content. If not right now, then in the long run. So just let us know. Like we have, I believe there's methods documented here to reach out to us, and we also have our forums. But you could, possibly post it on the Unreal forums. I check there, and I would, if it's something we can address, I'll make sure an engineer sees it, and we can try to get it resolved for you.
On that note, feel free to use the forum announcement post where we announced this live stream as well, to the topics we're talking about here today.
Yeah.
Yeah, why don't we continue? We're still gathering all the questions, and we'll go ahead and make sure we get to all of them, at least at the very end.
Sure. So yeah, I mean, as you can see, like a basic project, just like getting going isn't that difficult. Like, once you're, it's there because you'll get this menu option. I can turn it off, turn it back on. I can set different modes. And I'll show you those real quick, just so people understand. And let me max my frame rate out, right? Because I think I'm screen locked to 120 frames a second. Okay, there. So here I'm in ultra performance mode. So this is, as you can see down here from the debug information, this is 33% pixel information being scaled up 3 times in each direction. So that's a 9 times scale up, right? That's a lot of, that's like postage stamp size being blown up to a 1080p image. But you can see that it doesn't look that good. That totally makes sense. It just does not have enough input pixels to generate like a really good quality image at this low resolution at 1080p. And we outline that in our documentation. This one right here, developer guidelines. And these are guidelines. These aren't hard rules. We're not forcing anybody to do anything. But these are strongly recommended, and we find that they've worked for a lot of AAA developers and even some indies. So, if you step through this document, you can see, we document what everything is. we say right here, ultra performance is really intended for very high resolutions above 4K. That's why it exists. It helps to make 8K possible. And I think, yeah, if you do the math on that, 33% of an 8K image is 1440p, I believe. So, 1440p original image, that's a lot of pixels. So that's enough for it to work with in order to scale it up and make that 8K possible. But these other modes, performance, balanced, quality, are all good for a range of lower resolutions. You kind of just have to look at your content. It's just going to depend. Sometimes, like in the case of a ray traced image, I would highly recommend going with quality for almost any resolution. So you'll get less of a performance boost, but you will get a performance boost. And the reason why I recommend that is because the ray trace denoiser just needs like a bare minimum of input pixels right now in order for it to produce a good image. If you go too low quality on the DLSS, it's not going to look very good. But like I said, you got to look at your content too, right? It's like you might put your ray trace scene together and you're like, oh, performance looks great. So these are really just suggestions, and we talk about what all these are and what the suggested usages are. Yeah. Do you still have me?
Yes, sir. You're with us.
Okay, we got quiet for a second. I wasn't sure what was happening. So yeah, was there another question after that, or should I get back on track?
We got plenty. Let's see. We can cover some of the general ones. Daniel MN81 asked, will the NVIDIA DLSS plugin utilize the DLSS reflection smoothing, caustic meshing, and not sure what that word is, GI volume into the plugin, like what we showed off a few months ago?
I'm looking for the question in the chat.
It's way gone by this point.
Oh, it's way gone. Okay, so what was the question again?
Will the NVIDIA DLSS plugin utilize the DLSS reflection smoothing, caustic meshing, and sparse GI volume into the plugin?
Well, I mean, graphically it should work with everything. Like there's really no limits there. I mean, it'll even the release version even works in VR, and it works with forward rendering and OpenXR. So there's really no limits that I'm aware of as far as something it wouldn't work with.
I think the question was in regards if those features would be implemented as part of the same plugin.
But there's something in there about caustics. I'm not aware of any DLSS and caustics issue.
The question is in regards to, will those features be implemented in the same plugin as the DLSS one, or will they be part of a separate plugin or engine branch?
Yeah, I think that's separate stuff.
See, we had another question from a couple of questions actually in regards to using DLSS with the movie render queue.
Oh yeah, so I can jump to that project. This is because this is great to look at. We pulled down the Meerkat demo, sorry.
Oh, there we go. I think we're back. We had a little hiccup.
Oh,
give us just a moment. Verify that we're back live. I think we are. Gonna hit F5 right here. Twitch as well. Sorry, Richard.
That's okay.
Yeah, we're getting your stream. And the
Okay,
PC
you can hear me and everything?
Yeah, you're good.
Okay. No whammies, no whammies.
Working out. Yeah, we have you well on our end here. It seems to be only up to Twitch. Let's check YouTube. Seems to be YouTube as well.
Oh, geez.
There we go. Yeah, I think it's actually Twitch only at this point because I'm seeing you just fine on YouTube.
Okay.
Give us just a moment, y'all. If you can hear us, we're just figuring out some technical difficulties here, getting the stream live on Twitch. Yeah, we have zero issues on YouTube. All right. I think we're going to go ahead and try to restart Twitch. Sorry, all YouTube watchers. Got to make sure that everyone can enjoy the content.
Yes. But people on YouTube can still see me and hear me?
Yep, we are loud and clear on YouTube.
Okay. I don't want to give anything away yet.
Let's go ahead and do this. We're going to try a full restart here. So y'all watching on YouTube right now, we will be right back. Everyone is just chilling at this point.
Yeah.
We have excellent connection on YouTube, so it seems like we have some issue with going through to the Twitch server.
Oh my goodness.
We're back up on YouTube, and I believe we are back up on Twitch. Restart's good. Richard.
Ooh, yeah. Okay.
Sorry about that.
Right. Oh, it happens, right? Didn't you say before that there's at least one major glitch at least once in a while or something like that? I don't know. Something happens.
There's usually something when we're live, yes.
Something. Okay, so but you can everyone can hear me and see me.
Yeah, you're looking good. Your stream is coming through well, and we are live on both platforms, so you're good to go.
Okay. So yeah, I just wanted to. This is the Meerkat demo, and I think I'll just play it. Yeah. So this was, this is it was put out by Epic, made by some Weta artists, and. Oh, I'm not thing. Let me restart this. It's such a cool like demo. This is obviously very high end graphically, right? Like this is very close to CG quality stuff. If you haven't grabbed it and checked it out, it's worth taking a look at. But anyway, this is let me. Jeez. I'm going to try that one more time. Yeah, but here I've got so DLSS running on it, and it didn't come that way. I grabbed the project and added DLSS on top, and but you can see what this is doing for this rendered scene, because this was never meant to be real time, right? This was intended to be a movie file output using movie render queue or MRQ, and so a big question is like, well, can DLSS help to speed that up? Can it improve the workflow? I'll say that we're still looking at this. We don't have clear answers yet. Sort of where we're at right now is DLSS works great with Sequencer. Movie render queue, it's a little bit of a question mark. I think it's not fully implemented, but we're very interested in this area, and I don't, I can't make any promises about what might happen in the future. But this is an area of investigation for us, and we want to support it if we can. But anyway, I've set this up with DLSS, and you can actually see like what the differences visually, the quality differences. I've got whoops, hold on. Yeah, I've got a shortcut here for DLSS off, and you can see that on my 2080 Ti system, this is running at like just over 30 frames per second, about 35 frames per second. And then DLSS on, it's about 40, it's hard to tell what that is, 47, 48 frames per second. So almost, at least a 30 to 50% speed boost. We can look at stat GPU, because this is almost all GPU costs going on here. And if I switch back to standard anti-aliasing, full resolution, you see I got a lights cost. There's an RTX GI cost. There's hair strands, post-processing. All those things are fairly expensive because we want this to look quality. But a lot of those are screen resolution dependent. So when, not everything, but many of them are. So when I switch DLSS on, I get a significant boost in performance. And let's see, you'll notice it even pulls out certain details, like the hair strands. Here's in standard anti-aliasing, the hair strands get lost off the nose and top of the head and stuff. You can kind of see them; they're faint, like over the face and stuff, but they're not really showing up. But with DLSS, this is an area where DLSS can sometimes improve image quality in ways you don't expect, where it actually, can almost grab some of that subpixel detail and pull it out. I think we've shown examples on our website where it's a game like Death Stranding, where there's some sign in the distance and it's literally too small to read anything on it, but you turn on DLSS, maybe in quality mode, and it pulls out those words, sharpens them. You can actually read it. We need to start using this for criminal investigations, right? Like like scanning license plates. Anyway, just like CSI movies and whatever. But you can see you can see what it does to the image here. Speeds it up, and in this case, it actually it improves the quality. Sometimes if you look at the fur under his chin there, so here's with DLSS off, there's like a kind of a shimmer to it, like it's not stable. It's not like able to, fully resolve it somehow. With DLSS on, it not only pulls that fur detail out, it stabilizes it. Now, I don't want to get... Yeah, go ahead.
It also seems like depth of field is working as intended. We had a couple of questions of that in chat.
Yeah. No, depth of field will be different. If you look closely, depth of field totally works. This is actually a misunderstanding. Depth of field works with DLSS. All your post-process effects are going to work. But in some cases, namely DLSS and Bloom, they're going to work differently. And it may not give you the result you want out of the box. So you might... Because when let's say you're doing TAA or TAU, which is the standard anti-aliasing upsampled. So you're doing one of those methods, like where your post-process effects sit in the chain is going to be slightly different and give you slightly different results. So between those two methods today in Unreal Engine, you don't get quite the exact same post-process result, depending on how whether or not you've got that upsample flag on in your project. What your input pixels are is going to determine like how your depth of field behaves. You can see this for yourself even without DLSS. Just start changing resolutions and change that upsample flag, and you'll see different behaviors. So what's actually going on is DLSS just does it a slightly different way, but it sits in that the existing post-process chain, and So it's present, it's working, but it's going to give you a different result than how TAA currently looks. And in some cases, it might make it seem like it just goes away completely, depending on how your depth of field settings are set. Or in the case of like DLSS quality mode, the difference might be really subtle, almost non-existent. So that's just a quality thing. And we also recognize too that this is an area that needs to be improved. Like we're not happy with that, right? Like we would like it if ideally, as if you're setting up your movie or sequence, whatever, or you're using depth of field a certain way, you want it to be consistent across all resolutions, all different like anti-aliasing methods, et cetera, et cetera. So I'd say that this is something that we just need to keep working on, and I would hope that a future update will see improvements to this. But yeah, if I switch back and forth, so here's standard anti-aliasing, and then here's DLSS. I'll just like cycle back and forth a little bit. You can see it's still doing depth of field, just like I said, maybe not everywhere you want or quite in the same way that you intended. But that's where you can account for it. Like, like in the case of this project here, the Meerkat, it's intended to be rendered to a file. That's the whole point of it. Like I said, this was never intended to be real time. I got into a discussion with the Weta artists on that. They were like, yeah, we didn't think that people would be like running this in like a live application, like it's going to be part of a game, and it's a real-time cinematic. It's meant to be, movie render queue. That's the whole point. And so in that case, you could very easily just design your post-process settings to be ideal for DLSS. If that's your development machine and you're spitting out that movie file, to just build it for that right there. But yeah, in other real-time scenarios, this is something we need to improve for sure. So yeah, I get, I can pause it, keep going. And there's a lot to, oh yeah, sure. You want me to pause it again?
Oh, I was just going to say, chat, we're referring to, the typical scenario in a movie where you just go enhance.
Right. Yeah, exactly. Well, maybe DLSS has other applications beyond games. I mean, I'm largely talking about games today, but there's lots of potential for other things, including rendering video. Yeah, here I just paused it. So this is DLSS off, DLSS on. It's like a 50% speed boost. Mm-hmm. And look at all that back hair look at that, how it gets lost right there, but then pulled out and stabilized.
Yeah, it's actually coming through the stream pretty well too.
Yeah. Yeah, it's so, I don't know. I mean, we made this application, this variant of the Meerkat demo so that we can start to study these issues and understand it better. This also, just so everybody is aware, this also has a ray tracing off versus ray tracing on, so we can study those differences too. So we're trying to learn a lot about how DLSS behaves, how GI behaves, how ray tracing versus raster. The project was intended to be raster. So yeah, we're just we're using this as this is one test bed to try to understand some of these differences and then look for ways we can improve it. Because like I said, we don't want the software to, it's not like, it's at version 2 and it's done forever. That's not the point. We know it has, there's areas that can be improved. It can always be better. And it's also important for us to understand what the differences are too. Because we've looked at a lot of content, but we haven't looked at everything, right? So there may be interesting details that we don't expect. Like I certainly didn't expect that hair to pop out like that and stabilize. So that's interesting to me. Yeah, this is all 426 stuff, right? So like the hair and fur is brand new. Like we're seeing this for the first time.
Had a question from Hector Centeno. So enabling DLSS automatically disables and replaces temporal anti-aliasing?
Yes. Yeah, it's one or the other. But yeah, like let's say you do your standard sort of way of optimizing the rendered scene, where you maybe run the project at a lower resolution, like 70 or 80% res, and then you upscale that, and then you do like a tone mapper sharpen filter on top of all that. That whole set of actions gets replaced by DLSS if it's active. So yeah, you're doing one or the other. I should just let this play because it's fun to watch.
Yeah. I had another question from Wild Dog Studios. Do you control the native resolution manually, or does DLSS do that?
Well, you can specify the which or what resolution you're using depending on the quality mode. So I'll just back out here real quick. Let's look at our meerkat. He's such a cutie.
Yeah, I've seen it a lot in Zoom calls recently.
Yeah. So let's see if I set it to quality. Yeah. So like I said, it tells you at the bottom if you've got the registry key set up. It tells you what's going on. If I set it to balanced, that's 57%. This is performance is 50% resolution. Ultra performance is 33% resolution. And I think I might have just bit it.
If we don't have at least one engine crash during the live stream, it's not live.
Yeah. Right? The meerkat thing is very taxing. Like I said, I've got a 2080 Ti in here. It's a good card, but oh wait, no, there it goes. It recovered. I thought I was going to have a GPU crash for a moment. Geez, what's going on? I think I'm just gonna.
So, but those settings are predefined, right? But you also have the option to set that percentage yourself.
Yeah, you can. Yeah, there's a way, I believe, to specify that, or at least I'd say check the documentation on that. We do have. I can say that we are working on. I mean, like I said, you can specify it for an end user, or you specify it yourself. Where this is the quality mode I want to be in, and you set that up however you like. But one thing we're working on is variable rate shading or dynamic resolution. So it's partially implemented right now. It's there. You can play with it, but this is not like a final implementation at all. But I can show that real quick. Like, because the future of DLSS might be this, right, where you don't even specify the input resolution. The system is making very intelligent, dynamic decisions about frame to frame what the resolution is. So the command, and this is, like I said, this is a beta if you just want to experiment. But it's R test, and you notice there's some fun stuff in the R test category. But this one is dynamic resolution hell. And then you turn it on.
Always
and
fun
things. Yeah, and then you see what's happening down there. Look at that. The input resolution is changing rapidly. It's sort of cycling between different, like whatever it perceptually thinks is like the right resolution moment to moment. There's, it depends on the application. That could be a small boost to a big boost. And like I said, I'm very underscore. This is a beta feature right now. We're working on it, but theoretically, like I said, maybe in the future you don't even set the resolution. Maybe it all just handles it for you, sort of giving you the optimal frame rate based on what makes sense in the moment.
Cool. We did have some questions about the using DLSS with the MetaHuman project. I believe we were going to cover that, right?
Yeah. How are we doing on time? We're an hour into this already? Oh, my goodness.
But we got plenty of time to go.
Okay. I'll load up MetaHumans. Yeah, I personally, I'm really appreciative that, that you guys are doing all these sort of high-end projects, MetaHuman, Meerkat, because, I mean, this is a good way for us to make sure everything is working with it, including, but especially DLSS. We need to keep looking at, as much kind of varied content as possible. But these high-end projects that are like really GPU intensive are good test cases for us.
Waiting for this to load.
Yeah.
Yeah, a little bit. Maybe we can take another question while we're waiting.
Sure.
Let's see, we covered depth of field. Rafael Medeiros Lima asked, will DLSS have problems with screen space reflections?
No. Shouldn't. Any graphical feature you can think of, it should operate on really great. I mean, like I said, most of the time, at least 90% of the time, if it doesn't have visual equivalency to standard anti-aliasing, it might actually enhance your details. It'll depend, like I said, it'll depend on what your input resolution is, it'll depend on what quality mode you're in, but the potential for it to actually improve your details is there while giving you a better frame rate. I will note a couple of areas where, yeah, DLSS could improve. I mean, as long as we're on that. And we already talked about one of them, which is post-process, specifically depth of field and bloom. There are, I guess you could call them asterisks, things to be aware of that might affect your project. It's not going to affect every project. Another area is world space post-process materials. And if you think through the logic on that one, it makes sense. Because, if you have some type of post-process effect and it's specifically tied to world space, the way it works currently is it's counting on world coordinates to sort of match your screen resolution. And if you're working with less input pixels, in the case of DLSS, world space post-process materials won't render in the correct place. It's really just a known issue. And if you're really good with math, you can actually work out the differences and compensate for that in the material. So if you were like in DLSS quality mode, but that's 66% input resolution, you could do some math on your material and compensate for that so it looks correct when you're in that mode. You just need a couple of extra blueprint functions and something like that, and then it should work okay. But that one's come up, and just because there's a sort of a way to deal with it right now doesn't mean that's like we're happy with that, right? Like we would like it to just work if possible. So these are areas where like we always want to try to improve it, make it a little bit better if we can, fix anything up that we can. Like it's actually kind of important for us to get that feedback. If people have a particular project and something is just not playing right, and you've done everything you can, you've stepped through the more advanced settings and nothing seems to fix it, just get in contact with us. I'm on the Unreal Engine forums. You can find me there. You know, I don't post all the time, but at least I try to get in there, check it at least once in a while, and just flag me down. I will. If it's like I said, if it's something we can address, then we will.
Thanks, Richard. Yeah, let's
Sure.
take a look at this.
Yeah. So okay. So no DLSS. It's obviously a very GPU bound scene. Let's do a stat GPU. We can see exactly how we're spending our time. A lot of time being spent on lights. That makes sense. I think there's a number of like point and rect lights in here that are all shadow casters. So, you know, DLSS will more than likely have a good impact on that. You know, most of these other things, like I said, it's gonna improve your GPU time. So I can just turn on quality mode, and don't worry, I'll take well, maybe I should just move this right over here so we can see the quality differences. But you can see what that did to the frame rate. I think I went from 20 some, maybe 25 frames per second to almost 40.
Mm-hmm.
Cut the lights time in half. That's huge. You know, I'll swap back, turn it off. Yeah, in this case, I'm not sure if it's improving any detail. I don't think it's losing any detail, like her eyelashes and it, you know, everything. So this is just, I think this is just, yeah, this is just standard anti-aliasing. If I switch to quality mode. Yeah, I don't know. That looks pretty preserved to me, but it probably could be gone over with a fine-tooth comb for like image comparison. But yeah, the performance gain is definitely there. It affected almost every category. It's not going to, like I said, if it's not a screen space effect, if it's not like a sort of a like a fill rate issue or strictly a GPU type issue, it's probably not going to you know, impact it. So you know, that's why it just depends on what you're drawing, right? This gets to that whole point, is that depending on what's in your scene and how you've constructed it, the gain can be a little bit. It might be 10 to 20%. It might be a lot. It might double your frame rate. I think under very ideal conditions, it's more than double. But you know, so that's why there's some range there as far as it just, like I said, it depends on where your performance bottlenecks are at exactly. But you know, going from 25 to 40, that's pretty good. This is a very intense scene. I can give it a play.
And this is with DLSS on, right?
Yes, you can see it's active at the bottom there. I guess I'm running in balanced mode at the moment. I didn't. That is the default, so it just went right to it.
That shot right there is my absolute favorite.
Yeah, it's killer, right? It looks so good. I notice performance, it takes a big hit when it zooms in on his face, but yeah, I think before, for me, like in regular anti-aliasing, this is no better than 20 frames a second. And here it just, you know, we're above 30.
Had another question from Syntask in regards to using DLSS for virtual production workflows.
Yeah.
And I don't think that's a one solution fits all, right? Depending on what your production cycle looks like there. But something that would be of benefit is the real-time iteration benefits that you might see, right? If you have a very, very intense and performance-heavy scene, you might not necessarily need DLSS when you're outputting your images, unless you're seeing a sort of image quality improvement that you like.
Right.
But especially when it comes to iterating, and this is one of the great benefits of using a real-time engine for movies, is that you have the opportunity of having it run at least 24 frames, which is movie, while you're working on it. It's just make a change, hit play, look at it right away. You don't have to wait to see.
Yes, absolutely. Yeah, it's gonna benefit you on almost any GPU bottleneck task. So yeah, as you're working with something in real time, and if you can get a sense for that, is my GPU what's costing me? Like here, let me turn off DLSS, right? So turn it off. My frame rate goes down. Okay. So very basically, I can do a stat unit, right? And get a look at what my cost is. That tells me right there. If, game time can be like your, things like your CPU, your blueprint scripts, or whatever, your game code, basically. But here you can see my GPU is my highest cost, and you're only going to be as fast as your slowest component, right? So this is, that's why DLSS has a sort of an outsized impact on this particular scene, because my GPU cost, as you can see right there, is pretty high. So if I put it on, my GPU time went way down. I think it shaved like 12 milliseconds.
Yeah, it did.
Right. So that has a big effect. Not quite a doubling, but pretty good. And if it's a workflow thing, like you're just trying to get the most performance out of it, you could potentially go ultra performance, and it'll be blurry, or I should say blurrier. But now I just went past 50 frames per second, at least momentarily. So that can be a big help. But yeah, especially when talking about movie render queue, like I said, this is something that we need to further investigate. But there are interesting ideas there, because everything I've talked about so far is DLSS in like totally in a real time, usually typically a game, but maybe a visualization setting too, right? Where you're trying to maximize frame rate. Well, what if we took DLSS and ran it not at a lower resolution, but a higher resolution, and use that to enhance details that you might output in a movie? That's interesting, right? And at the moment, it's unexplored, but we're thinking about it, and I think we'd like to do it. But we need to look at it. But that especially tied with movie render queue, that might be where you don't run DLSS at a lower resolution. You run it at 100% or maybe 150%. It's sort of like how you'd typically, you'd go into you'd go here into the screen percentage, and you'd upscale it. Set it to some higher value, 200% or something like that. So it's not going to, doing it that way, setting it at 100% or higher is not going to save you any frame rate, but it might enhance your details. It might improve your quality beyond what you thought was possible originally. So that's an interesting area. Yeah, I wish I had a more clear answer about that today, but that's something that we're looking at.
Maybe the dork asked, does DLSS render operations happen before UMG Slate UI or after?
I think, well, that stuff can be completely resolution independent. So it leaves it alone as far as I know. Like if you do upscaling right now, like the UI elements all project at 100% resolution, and that doesn't change.
Can't pronounce that name asked, are there any circumstances where DLSS might become a downside? And what would be the worst case scenario?
Becomes a downside. Well, like I said, there's the aforementioned world position offset material, post-process material issue. But that's a known one, and like I said, we would like to improve that. And yeah, just in the current render pipeline, the way things are currently set up, it's just good to be aware about how your post-process effects might change. That totally depends on the project, right? How much bloom are you using? What are you doing with depth of field? Some games don't use depth of field at all, and some games turn their bloom off, or make it an option. So it's just going to depend on what you're currently doing. But I think my point there would be knowing about these things ahead of time, these like sort of edge case issues or known issues. If you're aware of them, you can sort of build it into your plan for DLSS. I mean, our experience generally with working with developers has been it's always much easier to know ahead of time what the technology is and what you're dealing with. What are the strengths? What are the weaknesses? Just what does it do? And the sooner you can get that into the process, the better off you're going to be with your project. If you've got something that's like basically done, your final beta, you're heading towards your gold master, you're just about there, and you try to add DLSS on top, you could run into some problems that way where you got to go back and change content. So yeah, just the sooner you can be aware, and that's part of the reason why we're doing this today, right? Is the more knowledge you have on it, the better off your project is going to be.
And that doesn't only apply to DLSS, right? There are always upsides or not always, but frequently upsides and downsides to the features you decide to use.
Oh yeah, absolutely. Like, I mean, we see this across the board with just about everything. RTX GI, ray tracing in general. The sooner people can be made aware of what the options are and how to make use of them, typically the better your production is going to be, the easier it's going to be. The hardest thing to do is the game is done, the project's done, and now we're going to try to take this advanced feature and go back and graft it onto that. Because then, like, maybe, who knows what you've made, right? Like, you got lots of different stuff, lots of different types of content, lots of different scenarios, and it's all been fine-tuned to the previous way of rendering things, whatever that is. And so yeah, that's, I mean, like I said, that's part of why we're doing this today, so that help people be aware of exactly what DLSS is doing, and just what to watch out for. But as you can see, you don't have to watch out for very much. Like, I'm not aware of a ton of issues, and like I said, in a lot of cases, you might find that the quality actually improves, which is crazy, but true. So, not in every case. I mean, like I said, little details can come up where it's like, yeah, it enhanced this detail here and made it better, and God, I got an extra 20 frames per second, so that's wonderful. But maybe this other detail over on this part of the image, I feel like it took a step backwards, and so we just take those case by case. Like, how can so we look at it, we want to try to make these improvements.
David019 asked, can you selectively use DLSS? For example, in a first-person shooter, don't process the middle of the screen.
No, but that's an interesting idea. I'm not sure how much performance benefit there would be if it were possible to mix different modes like that, but it's an interesting idea.
It falls in line a little bit with how variable rate shading works, doesn't it?
That's true. Yeah. It doesn't work that way currently, but who knows what's in store for the future.
Yeah, it's definitely an interesting idea.
Yeah.
Might even be some cool effects, and I don't know. There's always so much to think about.
Yeah, exactly. Well, yeah, I mean, and rendering today is a very complicated affair, right? Because you have all your post-process effects, you have maybe different translucent layers of different like Niagara effects or whatever you're putting in the scene. There's a lot of different kinds of content that all comes together, and it's not all rendered in one shot, right? Like there's different passes that are happening, and they're happening at different stages in the render queue. And of course, we're trying to do it all really quick, right? We want to do it in, a tenth of a millisecond or some number that's really, really low. So, there's big challenges there, right? It's a lot of difficult things to solve. We want to do it as fast as possible. ideally everything would be running at 1,000 frames per second. Frame rate would never be an issue, right? Like it just runs, no matter what you throw in there. So, you know, I think this is where it starts to get a little theoretical. But anyway, you know, who knows what the future brings? Yeah.
Yeah, let's we're still gathering all the questions here. But why don't we move on with the presentation?
Okay.
I know you have some more cool stuff to show us.
Yeah. Okay. VR comes up a lot. So I can't show VR in real time. So I'm going to show you a video. Okay. Hold on. Let me do this. Do a zoom to fill and a repeat. Anyway, I wanted to show some kind of VR thing just to show everybody that this actually works, and it's potentially very good for your VR project. This right here. This is not a product. This is not anything. This is just me messing around with an idea I had at home, because in a former life I was a VR developer, and I have a strong interest in VR. And someday I'd like to build a home theater in my house. I'm not rich, but it's cool to dream, right? So I started to game it out. I was like, well, I could just use Unreal, and I've got a VR headset, and I could like build something to scale virtually and sort of like game out. What does it feel like? Does this make sense? That sort of thing. So this is all like a theoretical room space in my house, and I wanted to see if I could make a like a virtual reality theater room, just to, like I said, so I could sit in it and feel it out and see what this is like. But I put DLSS on this too. I hadn't tried it before yesterday. Just to see what sort of performance I would get out of it. And as you can see, I mean, this is kind of set up for performance as is. It's running on a 2080 Ti, so performance is really good. But so now this is, this is, I set it for VR mode. This is with DLSS off, right? And you can see the frame rate's kind of variable. I actually, just so everybody knows, this is deferred rendering. This is lots of shadow casting lights. It's all dynamic. You can see the shadows there coming in from different directions. Way too many shadow casting lights. This is not like a realistic production VR project. Like, you'd want to optimize this more if it was like something you're putting out there. But like maybe as you're developing and working on it in real time, you don't want to optimize it as you go. Maybe you just want like good frame rate, like while you're building it. And like, like I said, like I think this scene probably has 20 shadow casting dynamic lights. Like it's too much. But it's it's VR. This is not ray traced. It's raster rendered. So yeah, like this is just, you can see what, I've got a simple function in there where I press the space bar and the lights go down, they come back up, the door opens and closes.
Yeah.
That sort of thing. It's just like I said, this is not a product, never will be a product. It's for my own purposes. But I felt like it might be pretty instructive on the benefits of DLSS. So DLSS off, and then here I'm enabling it. That's DLSS on. And you can see the frame rate jumped about 20 frames a second. In this case, it looks like it went down about 2 milliseconds. It went almost right up to like 120, and it's like pegged like right at like 119 or close to it.
When we're talking VR, 2 milliseconds is huge.
It's huge. Yeah, you're a VR developer. You understand that you're fighting for every fraction of a millisecond you can get in VR. Yeah, I mean, like I said, if you were fine-tuning the project and you had a lot of detail to draw in VR, more than you thought was previously possible, I mean, DLSS, it might almost be most ideal for VR applications. I mean, it's got, like I said, it's a lot of applications across the board, but in some ways, it's kind of really meant for VR. Because here in this case, so I turn it off. Look at the details right in the center. Look at the line structure, how it's, the high contrast area. Look how it sharpens and cleans it up with DLSS on. So not only did I get a frame rate boost, I got a detail enhancement. Yeah, there's standard anti-aliasing.
Yeah, and that's an interesting solution if you are required to use deferred render paths for whatever reasons instead of forward, right?
Right.
Temporal AA doesn't look great in VR. We all know that. It makes it rather blurry. And so if you can instead use DLSS to sort of enhance the image that way,
yes,
that's a win-win.
Yeah, and of course, DLSS does work. Like, it's intended to work with VR, so it does. It will work with forward rendering. It works with OpenXR. And I would encourage anybody, if you're developing VR apps and you want to use DLSS and you see any issues, please let us know. Like, this is an area that's important to us. We want to improve it. And make sure it's rock solid. But as you can see, like I didn't do any, like, you can fine tune the sharpness factor. You can do a few other details to DLSS. Like I said, I just set it to a quality mode. Got a small but noticeable frame rate boost, and it pretty much just works. I didn't have to do any other fine tuning to my project or worry about any other details or change anything or anything like that. And if you're an audio video file, you might notice in my hypothetical theater down here, I've got an ultra short throw positioned laser. I'm sort of into that stuff, so I think it's pretty neat.
Yeah.
Getting off topic, but anyway, any other questions at this point, or?
Sure. Yeah. Let's go through some of them. 4xPC asked, is there a difference between the DLSS 1.0 of the 20 series and the DLSS 2.0 of the 30 series in this plugin? Or does both gens use the same DLSS version of the plugin?
Both generations use the same version of the plugin. You might be playing a game, though, that's using an older version of DLSS, but that's just built into that game. But the plugin that we've released is I think technically version 2.1.5 or something like that, and it's that's the latest release, and it's the same plugin for any ray tracing card.
Let's see. Rare Bird Games asked, what happens if you optimize your game for DLSS but port it to console? It kind of throws me off.
Oh, sure. Well, yeah. I mean, DLSS requires Tensor Core hardware right now. So that means it requires an RTX card in a PC. It doesn't run anywhere else. That's how things are at. That's where they're at today. So if you're running on any other platform, you're going to use another, you're going to use a standard anti-aliasing or upscaling, or maybe some specific method that hardware offers. But that's really it. It's actually very simple.
CNorth asked, can you combine temporal upsampling and DLSS?
No. It is a one or the other thing.
That was easy.
Yeah.
Gideon October asked, is DLSS a final post process, or can you implement several layers within the image?
Several layers. I'm not sure I understand the question exactly.
Perhaps is it affecting several of the buffers, or is it after all the buffers? I believe as a plugin, the best way to understand it is there's a page on the Epic documentation that talks about
the whole TAA and TAU render queue, and you can see where basically temporal anti-aliasing resides in that chain. So if you go there, basically just DLSS replaces that. So you're doing one or the other, but it exists at that point. And it's going to depend on whether you're doing the upsample version or not.
Let's see. Robin Hassenbach asked, will DLSS be supported on mobile NVIDIA chipsets?
I don't have any kind of answer for that right now.
Cool. Let's keep some of the other questions in the end. I'm also gathering some general that we can cover a little bit later on.
Sure. Yeah. Okay. So I also wanted to show this project here. This is a game coming out called The Fabled Woods, and it's made by an indie developer. This is really a great. It's not out yet. It comes out March 25th, but it's really a great success story from a technical standpoint. The developer is actually a one-man team.
I think we lost Richard for
the developer Pumpkin Jack as well, and so they kind of end up. Oh yeah, is everything okay?
Yeah, let's just wait for the project to load. I think your CPU is taking a little hit right there.
Sure, yeah. I was launching it, so that makes sense.
Okay, check 1, check 2. I think we're good.
Yeah. Okay.
Yeah, we're good.
It's doing its thing again. Okay.
Yeah, well, at least we have you.
Yeah. Okay. So I don't want to show the whole game or anything like that, but I just wanted to show this is an interesting and really cool project because I mean, NVIDIA, is a big company. We work with a lot of AAAs. We work with a lot of big games, but we work with indies too. We work with a whole range of different developers, and this particular developer is really incorporating our technology. So they're using our NVRTX branch for optimized ray tracing. They're using DLSS. They're using RTX-GI. They're doing a whole bunch of things that are really powerful, and they're using it to produce a ray traced forcing. This might be one of the first to be done on this scale. And I mean, I did want to show you a little bit of that content because I think it speaks for itself.
Yeah, you showed me this yesterday, and I was quite impressed, especially considering the difference between this scene and the one you showed in your in the previous stream we did. We can tell that Richard's PC is once again loading a scene. I believe he'll be back momentarily. All right, scene loaded into memory. Let's see if Discord gets a little bit of that back.
This is there it goes.
All right, I think we can. Yes, we're back, Richard.
Okay. I guess it needs to rebuild some shaders for some reason. Even though I just loaded this, just before the stream started, it needs to do this. Can you hear me okay?
Yeah, you're good now.
Okay. So anyway, it's very interesting from a technical standpoint. I mean, I think this is going to be a really cool game. This developer, they really want to tell a story. It's a single player story-driven game. But I wanted to talk a little bit about it from a technical standpoint and how DLSS is benefiting this because he got our plugin and incorporated it, and like I said, largely it speaks for itself. So this is a it's not necessary. This game it's ray traced. It's also does raster. It does both. But this is a ray traced forest on a very large environment with a ton of foliage overdraw, and this is normally pretty killer, right? Like this is really difficult to do in any setting, ray tracing or not. But you can, but anyway, this is without DLSS on, and it's hanging in there on a 2080 card. It's getting a good frame rate, but we can do better. So go
enhance.
There we go. I put in this particular case, performance does great in terms of quality, and like I almost doubled my frame rate, and real time, reflections, not fake ones. Ray trace shadows over everything, over a very complicated environment. I think, like last time we talked, I showed a test forest scene because like this is this type of environment is something we would like to make sure runs at a really high quality and really fast all the time. And so we've spent a lot of development effort to help boost that, optimizing foliage and how it behaves and all that sort of thing. And I want to note too, because sometimes it comes up, people ask about our branch, the NVRTX branch, which anyone can get. They get access to the source code with a sign up. So you go to GitHub, you sign up. Once you're in there, you have access to the source code. You can see it all for yourself. But people ask, like, NVRTX. Well, how custom is that, right? Like that sounds like it's only going to work on NVIDIA hardware. That's not the case at all. NVRTX is it 100% follows DXR standards. So that's Microsoft's DX12 ray tracing standard, and NVRTX follows that 100%. The only thing that doesn't follow DXR standards is DLSS, and that's because it's not a ray tracing technology, for one thing, and another thing is that it requires Tensor Core hardware. That's tied to the hardware. But everything we do would run on any ray tracing hardware. It would run on a PlayStation 5. It would run on an AMD. It doesn't matter. We'd like to think that on our hardware it runs the best, but we're not doing any specific optimizations. Zero optimizations for our hardware. And like I said, the proof's in the pudding, right? Like you can get the source code, you can go through it line by line, you can see for yourself. So it's yeah.
Got a request in that previous camera position you were in, if you could just toggle it on and off.
Oh, the ray tracing? Or the DLSS. We're talking DLSS, right?
Yes.
Okay. So yeah, that's DLSS off. And DLSS on.
Thanks, Richard.
Sure. Yeah, if there are any differences, they're often very subtle. I mean, we can also compare it to DLSS quality mode. There's still a significant performance bump.
Mm-hmm.
But that's like when you set up the preferences for your game. In this case, the user can choose what quality mode does he want. Does he even want DLSS? And set it up that way. And I'm pretty sure that this game is set up that way. So it's not required, but if you have an RTX card and you want that boost, you get to choose how you use it.
Yeah, I guess something that folks might be curious about is, are you aware, other than implementing the plugin to this project, are you aware of any other work that was done with DLSS to get it to run this way, or was it more just an implement and turn on?
No, most of the work, it was mostly just turn it on and turn it off. Yeah, a lot of, I'd say most of the work went into other areas. The reason why I talk about ray tracing so much with this one is because, we want ray tracing to work with all kinds of content, foliage and, moving animated shadows and whatever. And so this takes advantage of that. And we did a lot of work to make sure that part of it works. But yeah, DLSS tends to be very automatic, unless you run into one of the, like I said, the aforementioned, maybe a depth of field issue, maybe a bloom issue. Sometimes issues with motion vectors. We've documented that in the PDF. But yeah, since this particular game, like I don't think he's doing anything with depth of field, so he didn't, or very little. It's not like he's trying to like blur things at a distance. So it yeah, for the most part, DLSS just worked.
Awesome.
Yeah.
Definitely a case of let's just sit here and look at pretty pictures.
Yeah, it is. It is pretty to look at. This actually has it's come up occasionally. People will notice this is that it. Whoops, I'm selecting everything now. There's volumetric fog shadows going on. That's something we have fixed in our NVRTX branch. So in ray tracing, you can get volumetric fog in ray tracing. But yeah, like I said, our code benefits everybody. People often have that question. Like, there's lots of, there's really small one-man teams like this project. There's big AAA games, and there's everything in between. We do a lot of interacting with developers that might be a 10-man team or a 20-person team, and and they've got maybe a PS5 version of the game planned. It's a common question. Will this technology work on other platforms? Yes, absolutely. DLSS, of course, it won't, but that's not today. I'll say that.
Yeah, I think you mentioned that the plugin that's available is still in beta officially, right?
For what are we talking about? For
the DLSS plugin for Unreal Engine.
No, the dynamic resolution feature is a beta, but I mean, what we have is I think it's considered release code.
Okay.
Yeah. You're ready to be used in any project.
Enhance,
exactly.
Stuck on that now. See, we've received a couple more questions here. Let's see if any of them are related to the project here.
Oh, sure. Yeah, and let's see. Yeah, I did want to. Well, I mean, yeah. Let's see if there are any other questions, though. I don't want to miss anything if people are wondering about something.
I think you're good. Why don't you continue, and I can mark some of them here, just to make sure that we'll get to them.
Okay, I did want to take some time to talk about some things we have coming up that aren't specifically DLSS related, but if you're ready to move into that, I'm ready too.
Yeah, let's go.
Okay. Well, okay. So if we could pull up the RTXDI page, or I don't remember what we were going to do with that. If I can get control, but
we got you. It's up.
Okay. Cool. So yeah, if you RTXDI is a ray tracing technology we have coming out very soon, and I really just want to put up. This is a public page we have right now, so you can go to this this web page right now and read about it. This is going to be coming to Unreal Engine, and this is a very big deal from a rendering and lighting standpoint. RTXDI it's just fundamentally going to change how we light scenes. Using ray tracing methods, basically new denoising methods and new lighting methods, new shadow casting methods, it is going to allow you to have what basically amounts to unlimited light sourcing. I don't know if this one can be overstated enough as being the big deal that it is. Not only are you going to be able to have literally thousands of shadow casting lights in your scene, but you are probably going to be rendering the scene faster than you do today. So, and this is strictly software. These are software improvements using the existing hardware to enable new forms of rendering. I mean, I'm blown away by this one because if you look back at the history of like modern gaming, the sort of the turning point for like modern 3D rendering was somewhere around like Doom 3. Doom 3 comes out, and they have hardware-based shadow casting lights, and they were working with pretty hard limits that we still work with today. Like you can Doom 3 was like you can only have like 4 shadow casting lights in your scene. That's it. This changes all that. It's going to change it radically. So you could go crazy with shadow casting lights, and you don't have to worry about culling them by distance like we do now. Where you set like a max draw distance on them, or maybe put stuff in a different sub level and stream it out. You have to worry about any of that stuff. And I mean, we'll have more to say about this coming up. I just wanted to put a highlighter on it, let everybody know this is coming, and it's a real thing. I've seen it working. It actually started as a technology under a different name called Restir, and as it gets moved into the Unreal Engine, it's called RTX DI. So yeah, direct illumination, and it's this is going to it's going to change a lot as far as what people thought like ray tracing was all about and what you could do with it.
It's very exciting. I showed the team yesterday as well, and I think we got some eyebrows.
Yeah, I don't think it's I don't know. It's probably not going to be any secret that we not only do we want to get this in everybody's hands and make it as accessible as possible, we want to we want to work with you guys, with Epic, so that this is a technology that we're coordinating on now and into the future. And just like everything else we do in the NVRTex branch, this is not tied to our specific hardware at all, right? It follows the same DXR standards as everything else. So, the software that we're developing, in theory, benefits the whole industry, and maybe in the future it allows for, some future console or who knows what, where we're doing unlimited lighting there too, maybe even on your phone someday. So potential is huge. I mean, this gets us potentially another step towards eliminating baked lighting completely, right? And just dynamic everything all the time.
Going through our questions here.
Oh, sure.
Did you have anything else, Richard, before we go move on?
Yeah. I just wanted to let everybody know that GTC is coming up next month, almost exactly 1 month from now, and GTC is our yearly technology event, and it's this year, with everything that's going on, it's online and it's free and open to everybody. So I think if you register, you can see all the conferences, you can see what we're talking about. There's going to be a lot of Unreal Engine related stuff discussed there, in whatever ray tracing, DLSS, other technologies. So yeah, I would just encourage people to check out GTC. And also there's we just opened up a really interesting contest with the marbles content. If you can load up that page, Uh,
We
uh,
didn't that one, but I can go ahead and link it in chat for everyone to view.
oh, sure. Yeah. Okay. That's good. Yeah. I just want people to be aware of that because we have this this other rendering workflow system called Omniverse, and in previous keynotes we had showed a thing called marbles at night, and it was like fully path traced. Really, the whole thing was to give us, it was rendered in Omniverse, but it gives you a glimpse of like future rendering capabilities. Ray tracing is where we're at now today. Path tracing is, well, it's the next step, right? It's it's if we can get that to where it's completely real time, for everybody, path tracing is where you might want to go. And so we showed the marbles demo, and it was a path trace scene, completely photorealistic. And we're doing a contest where we put out the marbles content. You can download it. There's a download link on the webpage, and construct something in Omniverse. But I would just point out, Omniverse has a Unreal 4 engine connection, so you can actually hook into your Unreal 4 content and do like path tracing of your Unreal 4 content using a different path tracer than the built-in one. But you can see all that, and we're doing a contest with the marbles content where you could win an RTX card. I think there's like a 3080 and a 3090 on the queue. So it's if you want to put something together, I just want everybody to know that contest is there. That content, by the way, is pretty cool. Like, it's really high fidelity, high detail stuff. We started to see, people in the community were sort of reconstructing it themselves. Like, I'm going to make a marble scene, like based on that Marbles at Night video, and just sort of reconstruct it themselves in one engine or another. And we wanted to actually put out the content and let people download it and mess around with it themselves. So that's up there. And so GTC, RTX DI, and the marbles contest is all stuff that's there now, or coming soon, and wanted people to be aware of it.
That's awesome.
Yeah.
Cool. You ready for a couple of questions? We can hammer out some of the ones we received.
Oh yeah.
Last time you were on, we showed off RTX GI and caustics and such, and I saw a few questions in chats in regards to what the state of those were, and if you were still required to download the NVIDIA branch source code of Unreal Engine to be able to utilize those. Yeah,
in the case of in the case of caustics, yes. I think we're keeping the caustics branch up to date with the latest NVRTX. I would need to double check that, but I believe it's been updated to 4.26. So that branch exists, and we still have goals with all of this technology, RTX GI, caustics, to make it more available. We would like to increase that availability. We would like to make it easier to get. We're not there yet. I don't have any announcement specifically on that today. I wish I did, but I can say that we're close to having an announcement, and there'll be more information.
Another question from Master One Gaming. Does NVIDIA DSR impact DLSS? Said you did DSR 1440p with a 1080p monitor. Will DLSS scale the image up to 1440p?
Is that DXR?
DSR might have been DXR. I'm not familiar with the abbreviation.
Yeah, I'm not sure I know what's being talked about there. DXR, just so everybody's aware, DXR is Microsoft's DirectX ray tracing standard. So that's just, if we're talking about DXR, that's a standard that we just follow.
Had a question, another here from Mippy the Dork. Any plans on using the underlying DLSS technology in other aspects of game development beyond final score image output? perhaps texture upsampling or such things?
I mean, no plans specifically, but those are all interesting areas, and I think we're very open to ideas. Like, the whole movie render queue thing isn't something that we initially thought about with the technology, but it's one of those things where once you start to prove that it can work, and that's really how DLSS started, because it was very theoretical to start. If you went back 3 years ago, the tensor card hardware was being invented. What is possible with AI self-writing software, and what can it do to images? What is it capable of doing? These are very powerful ideas, but it needed to be proven. Like, could it actually be done? And DLSS has proven something that was, like I said, 3 years ago was just theoretical. It's the technology like this starts to, I think it opens up our eyes to like even more possibilities, right? Like, well, what else can we use on this? Like, what are the other applications for it? So there's a lot of discussion about that. And yeah, if anybody has any ideas about what they think it might be good for that, I mean, like, please post about it. Please talk about it. I mean, we try to listen. We want to pay attention. We certainly want to try to execute on your ideas.
Hector Centeno had another question regarding the NVIDIA driver. Is there any performance difference with DLSS between the game ready and the studio driver?
None I'm aware of. It should be the same performance.
Sir Voxelot asked, does DLSS work on Quadro RTX 6000? I can't get it to work.
I'm not exactly sure. I'm more familiar with the 8000. I'm not so sure about the 6000. We can take that one offline, and I can get an answer to that person.
And for those who aren't aware, we usually follow up after the stream in the forum announcement post on the forums.unrealengine.com in the event section.
Yeah.
That's where you find all of the announcements for the live streams, and where we sort of continue the discussion around the topic that we presented on the live stream once we're no longer live.
Yeah. I mean, what I can say is that, like I said, DLSS works on Tensor Core based hardware. So if it's got a Tensor Core in it, it should work. I'm just not familiar exactly with the 6000 series.
Let's see. Navkrin asked, does DLSS use different model per GPU, or is it the same AI model under the hood regardless of the GPU? And so,
go ahead.
Are you planning to use better AI cores on Ampere? Ampere.
Oh, right. Yeah. Well, I mean, it's the same under the hood fundamentally, but it does scale up as the hardware scales up, right? So as you add more transistors and you make the AI hardware better, the software gets better, and we will be continuously updating the software and improving it, and maybe if little optimizations can be done, we do that. In the most ideal circumstances, if you've got something like a 2060, and you want to get a really good frame rate out of it, DLSS can do that. Like, it can enhance the game's graphics the same way it can for a high-end card, and hopefully do something like doubling the frame rate even there. So I mean, we just want it to be like a really solid, great quality and performance enhancement across the board.
Kentix95 asked, does UE4 handle the texture mipmap when DLSS is on? A lot of games using DLSS have blurrier textures due to the smaller internal resolution, and they forget to change the mip mapping.
I mean, yeah, it can definitely help with textures. You'll sometimes see. We didn't look at it too closely with the MetaHumans project, and it might be better for you for individually just pull down the MetaHumans project, put the DLSS plugin on it, take a look at it yourself. but it looked to me like there were like even like details with like the skin pores where it was getting just a little bit sharper and a little bit better. And that's DLSS operating on those pixels. So it's not just the edge of the surface, it's the whole image.
Batu asked, is there any relationship between DLSS and the upscaling tech used in the NVIDIA Shield for video?
I don't know, but that's something we can take offline too. I would suspect not, but I just don't know.
Another general RTX question here. Bob's definitely not your uncle asked, pixel offset doesn't currently work with RTX, which makes high quality blended scenes difficult to work with. Is there something in the works to fix this, or any recommendations to resolving the conflicts? I think this is a general Unreal Engine question as well.
Yeah, actually, I got educated on this recently myself because I was wrong about a certain detail. I thought it didn't work either. What's actually true is it works, but only in one direction. So the problem is you're trying to. Oh, sorry, I gotta drink something before I answer this.
It's all good. We've been going for 2 hours here.
When you're ray tracing shadows, and the problem specifically here is with ray tracing shadows, right? So if you're not ray tracing shadows, there's no issue whatsoever. If you're just doing reflections, or maybe, well, yeah, if you're doing reflections or translucency, I tap my mic. If you're doing reflections or translucency, you're probably okay. And if you're doing raster shadows with ray trace reflections, there shouldn't be an issue. But if you're ray tracing shadows and you've done that pixel depth offset and it's pushed outward away from the surface, the ray tracer doesn't know, because it's tracing off the literal geometry, right, in order to produce its where the shadows fall. So that pixel depth offset is just a material effect, and the geometry hasn't changed. So the ray tracer doesn't know like how to compensate for that, and there's no good way to do it right now. But if you pixel depth offset in the other direction, in the negative direction, it does work. So that's the issue just tends to be more limited. It can depend on like how much you pixel depth offset and in which direction, and then what types of shadow casting lights are hitting the surface. Now that's instructional, that's informational. Are we satisfied with that? No. We would like to make it better. We're aware of the issue. But I don't have anything to announce on that yet.
Let's see, next question comes from this place. With RTX DI using restir for denoising, do you think we could see restir for GI denoising in the NVIDIA builds?
Yeah, it's possible. I mean, when I don't when I don't know how much of this is public exactly, but I mean it's well known that Fortnite now has ray tracing, and we helped with those efforts in order to improve denoisers, improve performance, all that sort of thing. And I believe Fortnite has a version of RTGI currently implemented with an improved denoiser. And it could be that is not out for general development yet. So it's being used in Fortnite. And you would see this right now. I don't think that's like a giant secret or anything. You would see this if you loaded up Fortnite, turned on ray tracing, and you'd see some GI. That's what's going on. So we do like if you look at the RTX DI page, you'll see that improved denoisers are in the game plan, right? That's part of what makes this possible, is that like a technology like RTX DI, instead of doing it the way it's been done for the past 20 years, where we sample individual lights and cast shadows off of individual lights and process each light independently of every other light, is like, that's a very expensive way to do it. It works, it's just expensive. RTX-DI, part of that is improved denoisers. We have a separate page. If you surf around the NVIDIA website, you'll find a separate page talking about Watch Dogs Legion, I believe, and how they're using a next generation ray tracing denoiser. So our goal is, at a very high level, it's faster and better rendering, and better denoisers, and it's all linked together. Because if you can, instead of processing each light and shadow independently of each other, if you can do them all at the same time, so it's got one cost, doesn't matter how many lights you're doing, and then you denoise it in a more optimized way, where you're not only getting better quality out of it, but you're doing it in a different way that's faster as well. You sort of changed everything as far as how we light scenes. So improved denoisers are in the future, absolutely. And like I said, we've got public pages showing that, talking about that right now.
Next question comes from Bentrax. If I have DLSS version 02.11.2021 already installed and want to update to the new version 03.08.2021 for UE4, is it easy to update? I am a little afraid of it now.
Oh, yeah, it's easy. Just get the latest plugin and copy over what you've installed before, and you could just manually delete out the old plugin, put in the new one, and you're good to go. It shouldn't. I mean, you should be able. I've tested this personally, where change the plugin version, load your project back up. DLSS was enabled before. It's still enabled because it's that setting is done in the Unreal project, the U project settings, like whether DLSS is enabled or not. It's in the text document there. So you load up and it should just work.
Here's a pretty good question from Bassem Sameli. Is DLSS free to use in a commercial project, or do we need some sort of license from NVIDIA?
It's free to use. It's against the end user license agreement to redistribute our source, right? We want people to get our source from our website. We do this really just so we know who's using the software, how many people are getting the software. We're curious about those details. But once you get it, and once you build your binary and you distribute it, we're not asking anything from you at that point. It's you don't have to notify us. You don't have to do anything. It's your application.
I don't believe that is entirely true. I believe you are required to contact NVIDIA. There is a page.
Is there?
Mm-hmm. I was looking into this earlier too.
Okay. Yeah, please correct me. Please correct me.
I'm trying to find the link. For some reason, the marketplace page is not loading for me right now, and that's the route I remember taking last time.
Okay.
Can't find it within the next 10 seconds.
Right, here we go. But a person is free to use it, and I don't think we would. There's almost no way we would block somebody from using it.
Number 4, you are required to notify NVIDIA prior to commercial release of an application, including a plugin to a commercial application.
Okay.
Please send notifications to developer.nvidia.com/sw-notification. So there are a couple of, essentially notification to NVIDIA that you're shipping with it.
Okay.
Required based on the end user license agreement, but that does not in any way dequalify you from using it commercially. It is just a requirement that it is you notify NVIDIA.
Thank you for the correction. Thank you.
Now, when it comes to releasing games and when you're using, with native Unreal Engine, it's fairly simple. You're still required to notify us prior to release of your application. And the same usually applies to other resources. And so before you release anything, make sure that you read through the end user license agreement of all of the products that you're utilizing. Now, it's important, right? Because you're using software and products that other companies have developed, and you are trying to make money using those. And so just do your due diligence, read through the agreements, and make sure you don't have any angry emails in your inbox after a couple of weeks of releasing your game.
That's very good advice.
And that involves, it's fairly straightforward with the marketplace in general, right? All of the products on the marketplace go under the same end user license agreement, do not redistribute.
Yes.
Yeah, and a couple more. It's just a general advice to make sure that you cover your bases when it comes to releasing your products. And this includes if it's released for free in some instances, right? Even though you're not charging money for it, it is still a commercial application that you have submitted for public consumption.
Right. Yep.
Cool. Let's move on from the boring legal stuff and continue with the interesting technology stuff.
That's a lot of legal. Yeah.
Yeah. Yosimba asked, is there anyone, that's a funny question. Is there anyone credited with inventing the DLSS algos, or was the team behind it with a name?
I don't know the answer to that, actually. A lot of engineers, a lot of people have worked on it, and it's at this point it has become black box software in the sense that like we're fine tuning it and guiding it, if you will, and we make a plugin and so forth, but it's the core of it is it's self-writing software in many respects. So, it's a brave new world. But a lot of engineers, a lot of work has gone into it from a lot of people.
Next question might be a follow-up on our DSR, DXR question. But Philippe Magal has asked, could DLSS work together with dynamic resolution scaling to achieve a target frames per second by adjusting the render resolution on the fly?
Yeah. Theoretically, yes. We're not there yet. Like I showed earlier, we have a beta of dynamic resolution scaling implemented, and you can try it for yourself with a CVAR. But yeah, nothing else really for me to say about that yet. Just that it's on our radar, and we want to see it, grow.
Next question comes from Vanesoft Games. Any plans on bringing DLSS to web browsers? Could be a method to save bandwidth on video platforms.
Yes, that's an interesting idea. I don't have anything to say about that right now.
The next question, which is our last question. If you have anything else, we got a couple of minutes left. Make sure you shoot your questions to us before we go offline here. But next question from Wild Duck Studios is, will RTX DI run with DLSS in VR?
Well, in VR. Right now, ray tracing generally works pretty poorly in VR. It's not mature yet. I think it works, in some respects or in a limited way, but it's not there yet. Speaking personally, it would be great to see all these technologies play together. But I guess that's a future conversation.
Lotte Lava asked, am I required to buy an RTX 3090 to work with DLSS?
Oh, no, it'll work on any RTX card.
Any RTX card, yeah.
Yeah, you can, a 2060 is all you need.
Awesome. I think in terms of questions, that was it so far. I will scroll through this here, make sure I didn't miss anything relevant. I think that was it, actually. Richard, was there anything else you wanted to cover before I do my outro spiel here?
Oh, goodness, no. I don't know. We covered a lot of ground, and I'm happy we kept it. This is like 2 hours on DLSS, so there's that's a lot to talk about on just one technology. And I know we dipped into RTX DI and a few other things that are coming up, but there's a lot that DLSS has to offer, and I hope that's very clear.
I think so. Well, Richard, thank you so much for coming on today and showing off some pretty pictures, enhanced features.
Exactly, enhanced mode.
It is available. You can find a link to the developer page, NVIDIA's developer page, where you can download DLSS on the UE4 Marketplace, but you can also find a link on the forum announcement post, and I'm pretty sure you can just Google NVIDIA DLSS Unreal Engine, and that will take you straight to the link as well if you're interested in getting started using that. If you are new to game development in general and you've been enjoying the stream today and are curious about game development, on UnrealEngine.com, you can go ahead and download the engine for free, the launcher, then the engine. If you already have the launcher, just go ahead and hit the Unreal Engine tab on the left and download the latest build of 426.1, I believe is live. And you can also visit learn.unrealengine.com for a plethora of courses on how to do everything from blueprints to lighting to optimization. There's a great library of content, and make sure you also visit all of our community produced content. There's thousands of tutorials on YouTube, as well as conversations happening around our forums where people like to post them. It's two good channels there on the forums, work in progress as well as released. You can go ahead there and post your projects and let us know what you're working on. We're also always listening on Twitter, Facebook, and LinkedIn as well. Make sure you let us know what you are working on, and then we can potentially spotlight you as part of this live stream at the beginning. And if you go ahead and visit the launcher afterwards, we have a nice little screenshot there for your project. There are no physical meetups going on right now throughout the pandemic. However, some of the communities group at communities.unrealengine.com are still organizing virtual meetups. If you're curious about finding other like-minded, whether you're a game developer, someone who wants to dabble with film in Unreal Engine, there are plenty of other like-minded individuals out there who are excited about getting together and talking about these technologies, showing off projects, potentially helping out. It's one of my best memories, actually, is from Seattle when we were hosting the meetup over there, and we all got to show off our projects, give each other feedback. It's a great environment that you can find yourself in. To sort of get a little bit more of a connection to the all the stuff that you're working on. Like I mentioned the forums, but there's also a community-run Discord channel at unrealslackers.org. There are over 50,000 members, all talking about all the aspects of Unreal Engine and game development. It's an exciting place to be. Also mentioned there's another community group on Facebook as well as Reddit. And if you are curious about what I was going to say there. I started off the sentence wrong. If you would like to submit countdown videos for the live stream, please send us capture 30 minutes of development in Engine, and then fast forward that to 5 minutes, send that to us together with your logo. I know the main Stark just submitted another one the other day. I'm going to go ahead and get that into our roll of our countdowns that we do every week, but we're excited about seeing more projects, and we're looking for non-games projects as well, since Unreal Engine is now encompassing many more industries. It's not just video games anymore. If you stream on Twitch, make sure you add the Unreal Engine tag as well as the game development tag. That's the best way for viewers to filter your content if they're curious about watching Unreal Engine and development on Twitch, which can be fun. We're going to go ahead and raid someone, I think, as soon as we're done with the stream here today. Make sure you follow us on social media, and if you're watching on YouTube, hit that notification bell, and then you can see the next time we go live, as well as all the cool content that we're putting out on the channel. The evangelists are all, since they're unable to participate in live physical events, they are working on awesome feature videos for some new and some old features in Unreal Engine. I know that Andrea Suka, we just released yesterday the video on how to use Control Rig for a bipedal and a robotic spider, how you can use Control Rig to drive your animations dynamically at runtime. It's great stuff. Next week, we're going to have two of the developers from Mortal Shell on the stream. They're going to go behind the scenes of Mortal Shell, which is super exciting. I've been talking to them for a while. Happy to have them on the stream. Make sure you tune in for that if you want to see a little bit behind the scenes how Mortal Shell was developed and published. They're also going to talk a little bit about how you can be an indie developer and actually publishing your game, which can be rather scary when you get to that moment that you've been working on it for a while, but now it's actually time to release it.
Very impressive game, by the way.
Yes.
Yeah. I mean, we did a lot of work with them, so yeah, I'm very happy with how it turned out for them.
Cool. Yeah. Tune in next week if you want to check that out. And with that said, Richard, thanks again to you and for NVIDIA for coming on the stream today, showing off some of your new technologies. Yeah. Anything you want to lead the stream with before we go offline?
No, thanks everybody for being here today. Really appreciate it. And this was a lot of fun. I know it's just hope we can do it again in the future.
For sure, Richard. I would love to have you back on. With that said, I hope everyone stays safe out there. Have a good weekend, and we will see you again same time next week. Take care, everyone.
Bye.